Alright, today we're going to talk about acceleration. Before we go into acceleration, let's review a little bit for section 1. So let's go through these 3 questions. You can pose those in your groups, and you can pause it, and you can answer those in your groups. So what are the labels for the the y, or the vertical axis of the speed graph? What is the label for the x, or the horizontal axis of the speed graph? What is the speed of a car at the starting line of 0 centimeters? And what is the difference between distance and displacement? Give an example of each. So you can pause the video right now and go through those questions in your group. So first off, when we talk about a graph using speed, we will have the same label. So when you're graphing speed itself, your vertical axis, your y-axis, is always going to be distance. And your horizontal axis is always going to be time. So it's going to be a distance versus time graph. Distance divided by time is the equation for speed. And so it makes sense that that would be how you graph that. Another misconception you guys had in your lab: if a car is at the starting is at 0 centimeters, will it increase or decrease its speed? Some of you put it will decrease its speed. Well, at the starting line at 0 centimeters, your car is just sitting there. It's not moving. It's stopped. What's your speed if you're stopped, guys? You're right, it's 0 centimeters per second. So you have to only increase your speed. It may gradually slow down after it speeds up, but you will have to increase your speed before it can decrease, because you're starting at 0 centimeters per second, so you're not moving. And then what is the difference between distance and displacement? Remember, displacement is how far you've gone from a specific spot. So if I start in Warner, I go to Aberdeen, I go back to my original spot in Warner, my displacement is 0. However, my distance traveled would be 20 miles. And so that would be an example of both of those. So make sure that you guys went over that. So we're going to go through acceleration, speed, and velocity. Remember, speed is not the same as velocity. Speed, even though they have the same equations and same labels, speed is a scalar, while velocity is a vector, which means it has a direction. Acceleration is also a vector. Acceleration can either be a positive acceleration or a negative acceleration. If you are slowing down, so say I started, my initial velocity was 50 meters per second, and I went to a stop. Well, if you're stopped, you're at 0 meters per second. That would be an example of negative acceleration. And so your answer will actually be negative in this case. If I started at 0, which means I was stopped, meters per second, and I increased my speed to 60 meters per second in 10 seconds. Well, I'm going to have a positive acceleration there because my final velocity is actually greater than my initial velocity. And so you're going to have, don't freak out in your homework assignment when part of your stuff is going to be positive and the other part of your stuff is going to be negative. It's just how it works. And so when we graph acceleration, it is, if you look at the equation, it's velocity divided by time. And so your y-axis will always be your speed or your velocity, and your x-axis is going to be your time. By the way, this portion right here that you see, you can pause the video right now. You can actually write this onto your equation sheets. The whole thing. It's okay. Acceleration is typically labeled in meters per second squared, and it is known as your final velocity minus your initial velocity divided by your time. Here's a little hint. If I'm giving you something in miles per hour and then I said it took 6 seconds to get there, the seconds must be converted into your hours. Because if you're going miles per hour, you can't just divide it by seconds. You actually have to convert that. Remember, you have 3,600 seconds in 1 hour. If you want to write down your periodic table, go right ahead, or not your periodic tables, your equation sheets. Go ahead, you sure can. It's 3,600 seconds equals 1 hour. You're gonna have to convert and change those seconds into hours. Otherwise, you can't solve for your problems. I have an additional video attached to this that you guys are going to go through on the math problem portion of it. Their handwriting's a little bit better than mine right now, so I think it would be a better solution for you. So you're going to watch a secondary video. Also with this, you're going to have an acceleration lab tomorrow. Now, I read through your labs from yesterday. Some of you need to give a better explanation of what's going on. And make sure when you're graphing area is 75% of the space, and you must label your X and Y axis. You don't just get to write stuff on there and expect people to know what it is. So make sure that you do label your stuff, that you're using the appropriate space for this. Okay, have a good day, and remember to watch the second video to do your math problems.